This is my solution to lesson 32 of Paul McWhorter's tutorials on the Raspberry Pi. It's really an extension of lesson 31, where he has added more conditions to lesson 31's homework. First, he would like to be able to use the keypad as a way to enter some sort of access code. He suggests that the D key be used as an enter key. In addition, he would like the program to include a function to build the access code. So this is a demonstration of the program. I'll first enter all the keys. I won't enter the D key yet because I didn't want you to think that I had the access code pre-built, so I'll just enter another key to see what happens and then enter the D key. You'll notice the result does not include the asterisk and the hashtag, even though those buttons were pressed. I've chosen in the code to ignore those buttons. Next, we'll go to take a look at the code itself. This is the code for the homework in Paul McWhorter's lesson 32 of his Raspberry Pi series. A lot of the code includes code that Paul had in his examples in his videos. So at the top, we are importing the GPIO library and the time library. We're setting up the board in board mode rather than, or the GPIO in board mode rather than BCM. I have two arrays, one for the pins used in the rows and the other for the pins used in the columns. The rows are all set up as output. The columns are set up as input. They also include a pull-down resistor that's built into the Raspberry Pi. If we scroll down to the main loop, the try loop, notice we also have a keyboard interrupt exception. Well, in the try loop, I set up an access code string as empty, and then I keep looking for, I set up a while loop looking for that string not to be empty. So I read the string. If it's empty, it gets read again. If it's not empty, I print out the string as the access code. I do a GPIO cleanup and quit the program. Now if we look at the function, in the function you notice it includes arguments that include the row array, the column array, and the GPIO link. I set up a code string as empty again. I set up the code done flag as false. Then I have a matrix of 4 arrays that include the ASCII code for each label. I set a button state as 0, and for debugging, I print a message that says I've entered the function with a start function string. So I keep in this loop until the code done is no longer false. So as long as it's false, I cycle through all the rows, and I cycle through, and I set all those rows to high, and with our particular row high, I cycle through the columns, reading each column. If I read a value of 1, that means a button has been pressed. If not, I go down here and I set that row to low, and I go back up to the next row, and then I set the next row high, and then I cycle through the columns in that row again. If I read a value of 1, that means a button has been pressed, and I print out what I've read in that row from the matrix of the keypad. And then I keep reading that particular column over and over again. If it remains a 1, that means somebody's holding down the button. When it goes back to 0, that means it's no longer being pressed. Then I can read the button label. If the button label is not a D or hashtag or an asterisk, I append that button value to the string. If it's a D, that means that they've entered the D as an enter key, and I set the code done to true. Notice if it's a hashtag or an asterisk, it doesn't get appended. It's ignored. When it's done, it sets that row to low. It sleeps for a couple hundred milliseconds and returns the string. So that's the code for homework lesson 32.